La diffusion vient de démarrer. Tous les participants sont en mode écoute seul.
Good morning, everybody. I'm happy to see many attendees to our webinar on the adapted hydration method, a powerful tool now standardized for the Alveograph. My name is Bertrand Matthäus. I'm working at the Max Rubner Institute. It's the Federal Research Institute for Nutrition and Food in Germany. And I'm also the current ICC president. And before we start with our presentation with our presenter, Lena Bosch-Pionnet, she will give you some information about the method, also about the background, the benefits and the limitations of this method. And before we start, I will give you an introduction, if my screen works, how the webinar works. First, the technical procedure. The presenter, Lena, will give you the presentation. You can ask questions in the question box you should see on your screen. Please address questions to the presenter. And at the end of the webinar, we will address the collected questions to Lena. She will answer the most urgent questions live, and all the other questions that will not be answered live in the session will be answered afterwards in a written form as soon as possible. Before we start, I'll give you some few words about the ICC. ICC has been founded in 1955. It's nearly 70 years ago as the International Association for Cereal Chemistry, and it is an apolitical institution, and it is an international network for cereal scientists and technologists from around the globe. And today it's one of the most important international organizations in the field of cereal science and technology, and starts with international cooperations. One aim is the dissemination of knowledge and also the improvement of safety and quality of cereal-based foods. Yes, the ICC is a significant player in the coordination and participation in international research projects. It has organized a lot of international and national events on cereal science and technology. One main point is the development of international standard methods, and we also cooperating with other international organizations. And on this slide you see the activities of ICC. And we have a membership, different membership fees for different groups of members. If you need more information, please ask the office of ICC. The main point, as I said before, is standardization of methods. We have ICC standards. We have working groups for different kinds of topics. We are involved in different research projects, such as the Health Firm project. We organize a lot of conferences. You see on the right side different conferences in the next few years. We have awards for very honored members of ICC or other important scientists in the field of cereals and cereal technology. We have a mentoring program with the ICC Academy, webinars like this one, and also we are also involved in different initiatives like the Whole Grain Initiative. And the main point I already said, and that is the reason why we carry out this webinar, are the standard methods from ICC. And since nearly 70 years, ICC validated and published analytical methods in the fields of cereal safety and quality. And the main activity or the main objective of this activity is to improve the international trade, to give some help to the national and international legislation. We also, the standards are also introduced in ISO and CN standards, and it should be guidelines for the food manufacturer. The validated methods are published by the ICC collection, and now we have nearly or more than 100 international standards from ICC. You can buy them via the ICC online store. We have a technical committee that is responsible for the validation of the standards, and the head of this technical committee is our technical director, Valentina Naducci. She's working close together with 3 co-directors. And the last slide shows you the validation process, the standardization process. For example, you have an idea, you carry out some single lab validation, you submit this short description of your method to ICC, and then the validation process starts. And one core point of this validation process is ring tests that will be carried out by the method provider, and will be validated by the technical committee. And finally, the method will be approved by the General Assembly. And after 2 years, there will be another proof of the method, so that after 2 years, you have a final approval of the ICC General Assembly. This process should take half a year, a little bit more than half a year in the best case. And we hope by this way we can approve methods very fast for the provider. Yes, with this, I want to stop my short presentation of ICC. I thank you, and I will hand over to Lena Bosk-Villiers. She managed the food products and application team of KPM. And I guess, Lena, you will introduce yourself a little bit more, and also KPM. And then we are happy to hear your presentation.
Thank you so much, Bertrand, and thank you for the ICC to give me this opportunity. So let me just a second to share my screen. How is that? Can you see it?
Yes, it's good.
Perfect. So yes, my name is Lena Bosk-Villiers. I am working as a food product and applications manager for KPM Analytics, which is a global leader for scientific instrumentation and provides biosolution for food industries. So me personally, I am part of Chopin Technology. I am working there for almost 10 years. And Chopin is specialized in providing solutions specifically for the cereal industry, as you probably all already know. So thank you very much for joining today. I see in the participant list a lot of names that we know, a lot of names that we don't know, but names from everywhere. So thank you for taking the time and being with us today. And to speak about the Alveograph adapted hydration method, which is not a method that is widely used, but that is getting more and more recognized. The fact is that this method can give us an alternative. It can answer to different needs. It can improve some ways of working. And the best proof of that is that it has been recently standardized by the ICC, which provides really a recognized framework for an easy integration of the method in any process. And so this is really the aim of my presentation today, to explain this method as described in ICC 188, as well as the results obtained, the benefits, the limitation of these methods, and ultimately the goal would be to help you make informed decision about what method to use and why. So do not hesitate to ask questions in the question box during the presentation. I will try to answer everything by the end of it. So coming back first to the very basic of what is an alveograph. An alveograph is an instrument that will measure the rheological characteristic of a bubble of dough. So what we do is that we blow a bubble of dough. This is a very empiric method to start with, but by doing that, by measuring the evolution of the pressure of the dough inside the bubble, we are able to draw different parameters such as the tenacity of the dough, its extensibility, its elasticity, the way it resists the deformation, and a global values that is very well used around the world, the baking strength, the W value, which is the area under the curve. So this is a method that has been on the field for a very long time. The first Alveograph was launched approximately 1926, so it's about 100 years ago. Since then, the method has evolved, of course. It has been more and more standardized, more and more automatized, up to today, where we have now the Alveolab. But it was really introduced to the market 100 years ago. And it was invented in France, a country where most of the wheat used to be softer and lower in protein than in the US, for instance, especially 100 years ago. The wheat quality was much softer at this time. And the inventor of the Alveograph, Marcel Chopin, made the choice for ease of use, for time saving, to work whatever the flour quality at constant hydration. Meaning whatever the
Son coupé.
to absorb water, we always put
Son activé.
of water. And since then, this has been remaining the main use of the Alveograph, to work at constant hydration at 50%. Because of that, there is some sort of a dragon flying around, a myth that is very persistent about the Alveograph, that is not suited for strong hard wheats, that it's only for soft wheats. And that's, oops, sorry. I got myself carried away and I forgot about the poll questions. So you must have received the poll question. So please do not hesitate to answer. Thank you about that. So yes, the dragon flying around. So there is this myth, really, that the Alveograph can only be used for soft wheats because it works at constant hydration. We understand this myth, but the truth about it, the reality about it, is that there have been many studies about the Alveograph working with different kind of wheats, from soft to hard and even to durum wheats. If we just take an example, here those are some data extracted from the US Wheat Crop Report 2023, and we can see some data, Alveograph data, that we can see. So let me here. Some Alveograph data, P, L, W value for hard wet winter wheats. So a hard wheat, and also for hard wet spring, and up to the way to durum wheat. So that clearly shows that the Alveograph, even at constant hydration, is very relevant for any types of wheat. So that's the reality. But there is also something that we need to take into consideration, is that constant hydration may hide the reality of the quality of some flours. Because at constant hydration, there is a strong competition to capture the available water. All the components of the flour, all the main functional components of the flour, such as the proteins, the damaged starch amount, the fibers, quality and quantity, all of that, they are trying to absorb the water, to link, to bind with water. And that means that this water is not really necessarily available for all the other components to hydrate them at their full potential. And so as a result, the flour, they have a high absorption capacity. I'm sorry, I lost my presentation. Can you still see my presentation?
We can see it.
Okay. Okay, well, that's weird. So there is something weird. Okay. Oh, there it is. Sorry about that. I don't know what happened. I'm not very used to go to webinar, but sorry. So as a result of this intense competition for the water, flour that have a very high absorption capacity, so usually flour with a high protein content, high damaged starch content, they may be under-hydrated. And my presentation does not respond anymore. Okay, so try and yes, okay. So I hope this is the last glitch. But yes, flours that have high protein content, high damaged starch content, and so they can absorb a lot of water. If you always give them 50%, which is not a lot, especially taking into account the quality of the wheat today, they may be severely underhydrated, and especially the hard wheats. And so the idea would be to work at adapted hydration, just like bakers do, because bakers, this is what they do. Bakers, they take the flour, they mix it with water, with all the other ingredients, and at the end of the mixing step, they touch the dough, and they are reaching to always have the same feeling, the same consistency. And to do that, they adjust the hydration. So the idea would be to work a little bit more like they do at adapted hydration to be more representative of their reality, especially when working with strong hard wheats. The good news about that is that we can. There is an adapted hydration method that is available since 1998, and that has now been standardized at the ICC level. So that really provides us with marvelous support to implement this method. Why is that so important to have a method standardized, to have a standard associated to a specific instrument and a specific method? Well, it is important because it's a reference document that has been approved by a group of experts, of recognized experts in their frame of work, and that has been published by a recognized standardization organization. And that means that there is a document that details very precisely the methods, the reagents, the apparatus to use, the sampling method, the exact procedure to follow, how to express the results, and so on. And that ensures that the results can be obtained by anyone in the world, working from India, working from China, working from the US, or from Germany, or from France. Everyone should be able to obtain comparable results. And what does that mean, comparable? Comparable means that they are not too much dispersed. So we need to characterize the precision of this method. And a standard is also very important for that, is that because it describes the level of precision of the method. It gives us the fidelity data of the method, and that is key to speak the same language, to establish a consensus. Just to give an example about, let's take a very simple example about protein content. Like I'm selling wheat or I'm selling flour, and wheat protein content is a very important indicator. And so I say I want to buy a wheat with a protein content of 12%. Okay, is it 12% exactly, 12.0000, or is it 12 plus or minus 0.000001? We know that this is not achievable, and we know that because there is precision data that are here to give us a frame that allow us to base specification, to regularly purchase or selling wheat or wheat flour, to compare results with another laboratory, for example, between Miller and Baker, to provide laboratory information to a third party. For any accredited laboratory, this is more than important. So this is the basic. And now I would like to dig into more details about the ICC number 188, about the adapted hydration method as described in the ICC. So first of all, in this standard, you will find an important information, which is the scope. The scope describes in a very short paragraph what you can do with the standard method. Here, for example, taking this example, you can use an Alveograph to determine rheological properties of dough at adapted hydration obtained from soft to hard wheat flour. So any type of wheat flour, really, produced by industrial milling or laboratory wheat milling. That is important because everything that is not in the scope is not covered by the standard. That means that you cannot use the standard for testing during wheat semolina. You can test the semolina with the Alveograph. This is not an issue, but you cannot use the same fidelity data and you cannot say that you are following this exact standard. And then there is the principle of work that describes exactly what we aim to do and resume how the method is performed. Basically here, again, we are going to measure the behavior of the dough made of flour and salt water, working again at adapted hydration, and we will be measuring that by blowing a bubble of dough, and the obtained result is called an Alveograph. So that part really ensures that we know exactly what is the purpose of this method. And then we have the material to use. The material will specify the type of devices, the instruments, the reagents to use in order to obtain the expected results. So you have the reagents first. You need to use salted water. The concentration is precise. The storage conditions are precise. We have the oil, the type of oil, the quality of oil, the storage time as well is also very well described in the standard to make sure that everyone is using a material that will not affect the results. And then we have the apparatus. So we need to use a complete Alveograph system, including a kneading machine, including an Alveograph part and a software. And we need it to be an Alveograph. We need a system for recording the test environment conditions, so humidity and temperature, and we need a weighting scale. So this is important to follow what is described in the standard, because if you do use something else, then that may impact the results. That doesn't mean you cannot use something else, that you cannot use a type of oil that is not described here, for instance, but you need to prove with data that it leads to the same results, especially in terms of precision. So we will come back to the precision, but precision really strongly relies on the reagents, on the apparatus, and also on the method itself. So the method describes with the most possible details all the operation that the users need to follow in order to obtain the expected results. And concretely, very quickly speaking, for making an Alveograph test at adapted hydration, there are two main steps. The first step is to determine the optimum hydration level to determine the water absorption capacity, thanks to a first test that is called a consistograph test. That is a test that lasts 5 minutes, and basically we mix the dough and we press it against a pressure sensor. And the more under-hydrated the dough is, the more stiff it is, and the more pressure is applied against the pressure sensor. And we are basically directly connecting this pressure here, the maximum pressure, thanks to a regression equation, to the correct hydration to use. And then we just have to run an Alveograph test at adapted hydration following this hydration. And here the only thing changing is the flour weight. The software will indicate a different flour weight than usual. It's usually 250 grams. Here it will vary according to the adapted hydration, to the level of hydration. But the rest of the test is exactly performed as usual. You mix the dough, you extrude it, you laminate it, you cut it, you make the patty, you let them rest, you blow the bubble. But in the end, do not get confused between a result, do not mistake a result at adapted hydration for a result constant hydration to make sure that there is a clear difference. All the parameters, all the obtained results are indicated with an AH index. Then last but not least, we have the precision. So precision is actually very important. It tells us how much the results can be dispersed, and that would be normal. There is always an associated dispersion for any type of method, even the simplest one. And this is actually very well explained by my friend James over here. And the video, can I launch the video? I tested it and it was working. Oh no, yes. I need to get rid of the pointer. That's okay. So here is the video, and basically the idea is to say we are all starting from the same point, same method, same procedure, but all along the test we will encounter some events, some variation. Maybe the concentration of the salted water is not exactly 2.5 but 2.52%. Maybe here the extrusion has been done a little bit quickly than usual, a little bit longer than usual. We are still respecting the standard, but we are not always doing the things exactly the same way. And there is, of course, the precision of the instrument itself that we need to take into account. We have the method, we have the operator, we have the device, we have the ambient condition. Maybe it's 18 degrees, maybe it's 22 degrees, still in the standard, but that causes variation in the results. And this is what we are trying to measure, to assess with the precision data that is in the standard. Without this precision data, a standard is nothing more than an operator manual. And so this is why it's extremely important to have this information. And here, with any type of ICC standard, you will find two types of precision data. You will find repeatability limits. So repeatability limits detail variation that occurs when we do things always the same way under absolutely identical conditions. Same operator, same device, same laboratory. The tests were performed in a short amount of time. This is repeatability. And then we need to assess the reproducibility. And the reproducibility is the variation that occurs when we are not necessarily working in identical conditions. Even if we are not in the same laboratory, we want to be able to compare results. Even if this is not the same operator, even if we do test after 6 months. So this is called reproducibility. This is necessarily wider than repeatability because there are more events that can occur here in the system. So each method, even again the most simple one and the most complicated one, they have different levels of precision. And standard methods are really the only place where you can find a consensual information, consensual precision data. And that creates a basis for objective discussion between partners comparing results, setting up specifications during trading, agreeing on a level with someone else. So we know how to make a test at adaptive hydration. Now, what about the results and how can we compare that? How can we compare them with the, let's say, the standard results that we obtain at constant hydration? Well, we have both types of results. We have two types of results with the adaptive hydration method. First of all, again, we have the maximum pressure measured thanks to the consistograph that can be linked to the hydration. And then we have the Alveograph method itself that provides whatever the hydration in the end, rheological information about the dough, the tenacity, the elasticity, the extensibility, and the baking strengths. And so in the next slides, I will try to explain a little bit what are the interests of all of those data. So first of all, water absorption. With this method, we get the information about water absorption. And this is really key. I think I don't teach anything to anyone here, but water absorption is a key parameter for any type of bakers, because basically that allows them to produce more dough, more bread, or more final product at the price of water and not at the price of flour. So that's great, except for biscuits manufacturer who do not like to incorporate too much water, because then you have to remove this water during baking and that can cost a lot of energy. In any case, whatever the process, whatever the final product, water absorption is always critical to maximize the benefits, but also to avoid production issues. Because if the dough is too hydrated, then it becomes very sticky. And that is not necessarily a problem in our kitchen. We generally all try to make dough at home during COVID. So we know how to deal with sticky. We just put a little bit more flour on the counter and that is okay. But this is not feasible in automated factories, such as the ones that we see today. And that can cause a lot of problems, a lot of difficulties, and can go as far as to have to stop the production line. And that means a significant financial impact. If you want to learn more about the challenges of water absorption control, do not hesitate to go to YouTube. We have a very nice webinar about this specific topic. But in any case, the idea is that here we have access to this very important parameter. And then we have access to all the usual alveographic measurements, such as the tenacity, which is measured, this is the peak of the curve, really. And this is really meant to represent the stiffness of the dough. At constant hydration, the tenacity really represents how hard a dough is, how hard it is to push my finger into the dough. And so we could expect to have, at adapted hydration, very constant tenacity values. And the thing is that we have made the study, we have analyzed 150 wheats coming from all over the world, and we have made the test at constant hydration and at adapted hydration. And at adapted hydration, we have very variable results from basically 20 to 160. So it's far from being a constant, and that indicates that the tenacity is not equal to consistency. It's just one component of the consistency amongst others. But there is a partial relationship between tenacity at constant hydration and at adapted hydration, but usually the p-value at adapted hydration is lower. There is a small slope, which is logical. And then we have the L value. The L value represents the extensibility, basically how much air you can put into the dough before it breaks. It is measured, this is the length of the curve, really. And here we have tried to represent the extensibility in this graphic. So this is what we see here. This is the difference between the extensibility measured at adapted hydration and the extensibility measured at constant hydration. And in abscissa, this is the hydration that we used. So basically, we have said a little bit before that at constant hydration, there is a strong competition to capture the available water. So as a result, we have proteins that are less hygroscopic than damaged starch, for example, that may not get enough water to fully express their potential, their extensible potential in particular. And so here, this is what we see basically. What we see is that here we have a positive difference in this sector here. We have a positive difference between the L at adapted hydration and the L at constant hydration, meaning that we have a greater extensibility at adapted hydration. That's completely logical. That means that those flowers were under-hydrated. By providing them with more water, we give proteins all the water that they need to fully express themselves. the idea is that if you have a very strong flower, usually you have a peak and a very short L value. And then you process the dough on the line and the extensibility is correct. It's just not working in the same condition. So here we have a better idea of what is going on, of the actual extensibility of the dough. Then here in this sector, they represent flowers that require more water, more than 50%, but that on the contrary will give less extensibility. And this means that basically the hydration capacity here is not linked to good protein quality, but rather to damaged starch, which impacts a lot the water absorption and so the tenacity, the consistency of the dough, but not the extensibility. And then we have another sector here. These represent flowers for which we have given less water, and as a result, they are less extensible. It makes sense, and those are usually flour with low protein content, low protein quality, and low damaged starch content. And finally, here we have 3 atypical flour that when you give less hydration, they have a higher extensibility. So that's very atypical. We can here also suppose an impact of the damaged starch. We don't necessarily know to which extent. But the idea is that here at adapted hydration, the extensibility really reveals itself as it is shown, as it is seen by the baker. And then we have the most global parameter of the Alveograph curve. We have the W value. The W value is the area under the curve. It represents the work, the global energy required to deform the dough. And you should know that there is a strong relationship between constant and adapted hydration, but the W value at adapted hydration is always lower than the W at constant hydration. It's mainly due to the fact that the P value is decreasing, and this will have a strong impact on the W value. And that means, to take an example here, if I take a flour with a W value at constant hydration of 300, I can actually have a value at adapted hydration of 180. And so this actually, they appear to be much weaker. And so, of course, this doesn't change the quality of the flour. It is still the same flour, just analyzed under different conditions. But this observation here largely explains the resistance of some manufacturers to use the adapted hydration method, which is seen as penalizing the W value, not giving it its true performance. Again, same flour, just different condition. And in the end, we have the elasticity index. The elasticity index is characterized thanks to the curvature here of the curve. It's basically how the pressure decreases, how the dough relaxes after being, well, during deformation. This elasticity really represents a complementary parameter. It's how the dough returns to its initial position after being deformed. And very interestingly, we have a great correlation between the elasticity index at adapted hydration and at constant hydration. It is very little influenced by the hydration condition, and as such, it is a more direct indicator of the protein quality. By experience, working with partners, working with customers, we have been able to prove that there is an optimum IE value for every manufacturing process. So if I can give also very, what I think is a good advice, whatever method you use, constant hydration or adapted hydration, we can only encourage current and future users to give much greater consideration to the elasticity index. Usually it's not very seen in the specifications book, so do not hesitate to look into it. It's very interesting. So to conclude my presentation here, we can ask yourself, okay, which one do I choose? Constant hydration or adapted hydration? Well, in the end, there is not one method that is better than the other. At constant hydration, this is very fast. It only requires one test. It's very simple because you just require the moisture content to start. But it is also less representative of the reality. Whilst working at adapted hydration, this is showing more adaptability because we are analyzing flower according to their actual hydration potential, and it gives us a better representativity of what bakers actually do. But it's also a longer method. It also requires a larger sample size, and as the test conditions are not exactly the same, we are working in a different hydration, the results are less directly comparable. So in the end, this is a choice to make which one to use depending on an objective. If the goal is to compare, then your method, the ideal method should be constant hydration. Basically, if we can recommend the typical users would be traders, breeders also who needs a small sample size. And for people who need to get closer to the baker's reality, to better make the link with the reality of the process, then adapted hydration should be your choice. So yeah, that really depends on what you want to do. If you want to compare with another lab, if you want to trade wheat and flour, then usually simplicity and speed are preferred to productivity. But again, that depends on the objective. And so here now, we have a method that has been around for 25 years, and people have used it for 25 years, but now it has been standardized, again, by a group of experts. It has been recognized by the ICC, by an international association that says that, yes, Alveograph testing is possible with any type of wheat. So, of course, we have many users who still stick with the traditional method because they want to keep their historical records, but we also have more and more questions about the adapted hydration method. We see more and more people interested about that, and having this method standardized really offers, again, a recognized framework to be able to integrate this method in any kind of process, to do trading, to speak to design specification between miller and baker, by using a method that offers greater flexibility, that allows to really test flour according to their water absorption potential, and that gives us the assurance that we are working with a precise, well-established method with fidelity data included, and that has been internationally recognized. So I would like to thank you very much for your attention. Now, if you have any questions, do not hesitate to ask. Thank you very much.
Thank you, Elena, for your presentation, and thank you all for joining us. Maybe we can ask people to answer the last question that is on the screen right now. And the first question we have received is this one: is there any correlation between farinograph and alveolab adapted hydration?
Okay. I will answer in 2 steps. There is a relationship between the water absorption as described with the farinograph, as obtained with the farinograph, and as obtained with the consistograph. There is a good correlation. This is not the same value, but there is a good correlation. So that is that. Then, is there a relationship between the Alveograph data and farinograph data? Is there a direct correlation? No, I don't think so. I've never done the experiment, but I don't think so. Those are really different methods that are measuring different information about the flour quality. Farinograph will measure the development time, the stability to mixing. here we are not measuring that. We are measuring how the bubble of dough is being deformed in 3D. And maybe the second part of my answer would be a question. Why would you want to do this correlation? Meaning that those are different equipment providing different information, complementary information. So I'm not sure here a correlation would be interesting or useful.
So we have a second question. It's again about the Farinograph values. Can we use Farinograph values to do the adapted hydration? Alveo, I think you have already answered the question.
Not actually really, but yes, just to precise, here what I have described during this presentation is the standardized method. The standardized method requires to use the hydration provided by the consistograph. Now, if you want to go outside of the standard, then you can absolutely use whatever hydration, the one that is provided by the Farinograph, the one that is provided by the Mixolab, by Dolab, whatever really. It's just a different method, and that means that in the end you cannot use the fidelity data. You cannot compare yourself with other people using the adapted hydration Alveograph method. But you can do what you want. You just need to be aware of the limitations.
Okay, so another question. That's much more for the ICC. Will it be possible for ICC to share the method validation? So I don't think we have the answer. Lena's the answer.
Well, I'm not sure what that means, method validation. The documents, the ICC 188, can be purchased on the ICC website, if that is the question. And all fidelity data and ring test information are described in these documents. But here, yeah, maybe ICC could be more specific.
Okay. Another question, but it concerns the consistograph, and in fact, the question has not been fully explained. So if the people who is interested can send another again the question, that would be suitable to answer. And for me, it's okay. Another question. If you have to compare results with meters, how can you know what method they have used? Otherwise,
compare with
comparing to other results that are different.
Sorry, can you repeat the question?
So if you have to compare results with meters, how can you know what method have been used?
Okay, that's actually quite easy to spot. If you receive data from millers, you should ask for the curve. You should ask for the exported file for the curve themselves, and you will see that inside, either you have parameters that are noted P, L, W, IE, and so on, or you have P with an AH index, meaning adapted hydration, WAH, IE, AH, but all parameters obtained at adapted hydration have been obtained thanks to an adapted hydration method. So this is how you know precisely.
Okay, so quite a precise question now. According to scientific paper, without iteration, adaptation of parameters did not correlate well with final back good qualities. Is it correct?
If the question is there is not good correlation between the Alveograph at adapted hydration and the
final
process data?
The question is?
That depends. That's really here. That depends how you work. The truth is that yes, we have rarely good correlation, whatever the method is used, whatever the instrument is used, between any rheological instrument and the baking tests. Because let's consider volume, for instance. Volume is a very global parameter that is impacted by many different things, by the protein content, by the protein quality, by the amylase activity, by the starch characteristics, the starch gelatinization, the resistance of the protein to heating, and so on. And not all of that is measured or characterized with the Alveograph. So it's not that we don't have good correlation between the Alveograph and the final results, final baked good, is that it's just impossible to have a good correlation between any method, just one parameter, and a baked good. Then we can work with multivariable prediction tools that can help. But rather than predicting, what is much more interesting here would be to set up specifications, to say, okay, I need my WAH to be between this and that to obtain a good value. And because here we are working at adapted hydration, we are more representative of the reality of the process. And so we have more chance to set up efficient specifications. That's a little bit the idea, not necessarily to predict.
Are there many millers that are already using the AH method?
Sorry?
Are there many millers? Are millers using the adapted hydration method? Because the writer says that he has never seen a curved export with AH values.
No, you're right. This is still, it has been around for a long time, but since the classical method is used at constant hydration, it has had some, well, difficulties really being used, and also because it was not standardized. But the truth is now we see more and more people using it. I could not tell you a number, an exact numbers, but I can tell you that I received much more questions about the adapted hydration method today that I did 5 or 10 years ago. So this method is really increasing in popularity. To tell you an exact number, I could not.
BPR is also only working with constant hydration, right?
Right, that's right. To here, this is not necessarily the same objective. The BPR offers samples to make sure that your method, that your device is under control. So basically, this is an organization that sends every month the same flour to any participant of a specific method. You have a circuit for the pharinograph, a circuit for the mixolab, a circuit for the Alveograph, and so on. And for the Alveograph, yes, this is the constant hydration method that is used. But the idea of the BPR here is to follow up the quality of the method, the quality of the results. Since in the end, it does not vary so much, the method between constant and adapted hydration. If you do already the BPR at constant hydration, you can suppose that your adapted hydration method is under control. And if you need to make sure, we also provide reference samples to characterize the consistograph results. So if the question is how to make sure that the method is under control.
Is there a proficiency testing chain for this method?
No, there is not yet. No, as I told you, this is here the goal of the adapted hydration method is to get closer to Baker's reality. If you need to make sure that your method is under control, we have many organizations that are doing this kind of service. And again, to make sure that your method is under control, we can provide reference samples for the consistograph.
Farinograph dose stiffness, 400 BU or 500 BU corresponds to which dose stiffness with the Alveolab?
Oh, that's a very specific question. I am not even sure. Okay, so my understanding is of the question is that you would like to know the target, the consistency target that we use and how it relates to the Farinograph target. So here with the Alveograph, we have a target of 2,200 millibar. This is our pressure target, and according to this pressure, we will add more or less water into the dough to reach 2,200 millibar. Now the Farinograph works with a slightly lower consistency, so 500 BU, that would correspond to 1,700 millibar. The idea is not necessarily to work as the Farinograph. We are not making Farinograph tests. Is to be in the best condition possible to run an Alveograph test, to have a dough machinability that allow us to blow a bubble to have good results. So we are not working in the same condition, but again, not working in the same condition doesn't prevent us to have a good correlation between the hydration for the obtained with the consistograph and the water absorption obtained with the Farinograph.
Is the adapted method more used in Italy?
Italy? I don't know if it's more in use in Italy. This is generally, this is getting more and more used in countries exporting or using strong hardwoods. So we've seen a lot of people using it in the US, in Canada, in Kazakhstan, in Eastern Europe a bit, but also in the APAC area, in Asia Pacific area, because they use a lot of American hardwoods. About Italy specifically, I could not tell, but I don't know what every users are doing, so maybe.
Okay, so interesting question. Quite challenging. If we have Farinograph and extensograph, why should we use adapted hydration method?
This is just not the same tool. If you already have a Farinograph and an extensograph, then by default you are working at adapted hydration. Then the choice becomes, why choose the Alveograph over the Farinograph and extensograph? I feel like there is a lot of Farinograph users in the participants, but that's actually very interesting. So if the question is, should I rely more on a Alveograph than an extensograph? Of course, you know my my position. I would definitely choose the Alveograph for different reasons. Partially because of the precision of the method. If you look at the precision data as it is explained in the standard, then you will see that the Alveograph data are much more precise than the extensograph data. And also because here we are working in 3D. We are making a deformation in 3D, not in 2-dimension. But then again, that depends on your objective. If you have built your entire historical system on the extensograph and that you are satisfied with it, great. But if you still have issues, if you still have difficulties or challenges, maybe we can speak, and maybe the Alveograph is not the right answer. Maybe the Mixolab is, which is another instrument that I did not speak about today, but that could be very interesting as well. So it all depends on your specific constraints and specific challenges.
Okay, so we have maybe a last question now. What is the correlation between water absorption measured with adapted hydration and optimal water absorption for maximum specific bread volume?
Oh, wow, that's a very specific question, and that's actually impossible to answer, because that would considering bread to be a universal product with a universal process. As I told you, between the farinograph and the consistograph, we have different water absorption capacity. So a usual question that we get is, okay, which one is the best? Not a good answer. There is not a best prediction here of the good water absorption, because it depends of any process. If you are making pan bread in company A, in factory A, or in factory B, most probably you are not using the same ingredients. You are not necessarily targeting the same consistency at the end of the mixing. You are not using the same mixer, not the same process, not the same tools. You do not work with the same operators, even if in the end you are processing very similar final product. Because of that, the flour quality that you require for each factory is different. And so there is not one ideal water absorption for a type of product. This must be determined for any process, in our opinion. We can assist you on that. If you need help with that, do not hesitate to contact us. You have our contacts here displayed on the screen. Do not hesitate to use it. We would be happy to discuss further.
I don't know whether we have time for another question that we have just received. How precise is the adapted hydration water prediction based on consistograph? When working with other devices, sometimes many tests are requiring to obtain optimal value. Many tests are required to obtain optimal water addition.
Yes, that's true, and this is why we are happy to rely here on the standard, because we do have this information. This is in the previous slide that I've been showing. So if you go back a bit to the precision chapter, here you have the repeatability limits for the hydration, and here at repeatability, and here for the reproducibility. In both cases, this is a formula, meaning that this is more like a percentage. The level of dispersion increases when the absorption also increases. But this is something that we can calculate quite easily. Again, if you need support on how to calculate this kind of information, do not hesitate to contact us.
So we do not have any more questions.
Amazing. But of course, in any case, if you have remaining questions, you can again contact us. Oof. In the information on the screen. Thank you very much for your attention, and I would like to give the mic back to the ICC maybe for closing words. No?
Okay. So I hope you can hear me. Thank you very much for your presentation. Thank you very much all the attendees for asking questions and for being with us. And yes, I hope you learned a lot from Lena and her presentation, and we will see you on another webinar in the next time from ICC. Thank you very much and have a nice day. Bye-bye.
Thank you, bye. Thank you, Bertrand. Thank you, ICC.